Okay, folks, so this fun video is about comparing and contrasting elemental molecules and compound molecules. We just finished up atoms in the periodic table, but we're going to review some terms because you have to really make sure you know what things make up what when we're talking about the periodic table so that all of the stuff we keep building on makes sense. So, some review of terms. First of all, a simple one is matter, and that's anything that takes up space. Our next term is atoms, which I said we just finished, so you should know what an atom is, but it's the smallest unit of matter. Atoms make up everything. You should never trust an atom because they make up everything. That's a good dad joke. You should tell some people. Okay. Atoms are made up of protons, electrons, and neutrons, which you know because we just finished that, but just to remind you that they have a nucleus. Inside the nucleus lives positively charged protons, and the neutrons have no charge. And the way I remember that is that neutron starts with an N, and neutrons is like neutral, and proton starts with a P for positive. And that's how I keep those two straight in my head. And electrons are negatively charged. So negatively charged electrons are found on the energy levels. And you know the energy levels are like the circles that float around the nucleus. So those are just refresh your memory type of terms. A couple more. We have the valence electrons. Remember that valence electrons are located on the outer shell or energy level, like the very last one. So if there's 3 circles, the valence electrons are the ones on the last circle out there of an atom. This is a little too big. Let me see if I can shrink that in a little bit. There we go. The number of valence electrons affects the element's location on the periodic table. You remember when we talked about families and periods that depending on which period it's in, tells you how many valence electrons there are for that atom. Okay, then the periodic table of elements, we need to remember, a little grammar error there. I put effects instead of affects. So fix that on your paper. Anyways, remember that one capital letter is an element. For example, C equals carbon, N equals nitrogen. It's just one letter, it's just one element. If there are 2 capitals together, then it means it's 2 elements are combined. 2 atoms are combined. For example, CO is carbon and oxygen. We say it sometimes carbon monoxide. So that's 2 capital letters combined. If you see a capital letter and a lowercase letter together, it means it's one element. Like Cl is chloride. This part right there to the right is messed up. Just ignore all that nonsense. Okay, so elements are made of atoms. The number of protons determines what the element is. You know that from when we talked about the periodic tables. Elements are in their simplest form. That means they cannot be broken down into anything else. Even if you have a chemical reaction, they can't break down. They are what they are. When we combine atoms, we make molecules and other things. And a lot of these terms are kind of interchangeable, just like molecule, scratch that, just like atoms and elements are kind of interchangeable. When you're talking about carbon, you're talking about an element on the periodic table, but you're also talking about the atom for carbon. So those words can be used interchangeably most of the time. And so some of these other terms can be used interchangeably sometimes also. But you still need to know them all. Okay, so molecules are groups of atoms bonded together. A monatomic element is when it's made up of only one atom. Remember that mono equals one. So just like a minute ago when I talked about carbon monoxide, it was because it's made up of just one oxide or one oxygen. It was one carbon and one oxygen, and so we call it carbon monoxide because it's just one. And the stuff that we exhale is carbon dioxide because that's made up of two oxygens, di for two, which leads us to diatomic elements, which are also sometimes called diatomic molecules, and they are two atoms bonded together. Just like we said, di means two. And an example would be O2 or H2 or CO or HCl. Those are all diatomic elements because they have two atoms bonded together. Gets a little more complex. This is just a side note to remind you that they do not have to be the same element. Like it doesn't like O2 is two oxygens combined together, but it doesn't have to be two of the same elements. Like hydrogen chloride are bonded together, and those are still diatomic elements. All right, so elemental molecules are two or more of the same type of atoms bonded together. So, for example, O2. So a minute ago, I just gave you an example of O2 as a diatomic molecule. So that's where I said some of these things can be confusing because they can be used interchangeably. O2 can be a diatomic because it's two atoms bound together, but it's also an elemental molecule because it's the same element and they're bound together. Another example would be hydrogen, H2, or nitrogen, N2. So just like we have elemental molecules, we also have compound molecules. And compound molecules are two or more different types of atoms bonded together. For example, carbon dioxide is carbon and two oxygens bound together. So they're different. Carbon and oxygen are different, so it's two of those. Or H2O is a compound because it is hydrogen and oxygen being bound together. So they're different types of atoms being bound together. And then there's when compound molecules form, they can either be an ionic compound or a covalent compound. And we're going to talk more about this in depth later, but just to give you a brief summary on this. So ionic compounds is when the valence electrons, remember, so the electrons in the outer shell, the last ring around the nucleus, when those are given or taken from one atom to another. And I zoomed in on this. Let me see if this works. Okay, so I'm going to zoom in right now. So for this picture right here, sodium, which is Na, has 11 electrons total. On its valence electron, the outer shell is where I have this big red dot. Let me see if I can draw us a little arrow there, where that big red dot is. Oops, that didn't work. Let me see. I can get us an arrow in green. Let's use blue. That's where that big red dot is. That is the one electron on that third ring or shell for sodium. So it's hanging out there all by itself. And we're going to talk about this, or we already did talk about it, that each level of energy levels or orbits have a number that makes them happy. The first ring can only have 2, and 2 means it's full and it's happy. The second ring likes to have 8, makes it full and happy. The third ring also likes to have 8 and is full and is happy. But sodium only has 1 there, that red dot. And so it's just hanging out all by itself. Then if you look at chloride, chloride has 17 total electrons. And that means on its last ring, 1, 2, 3, 4, 5, 6, 7. It has 7. And so for it to be happy and full, it needs 8. So this 1 that's hanging out over here on the sodium is going to jump back and forth between sodium and chloride. And that's going to help. That's going to be what helps them bond. And they're giving and taking it. It's giving it away. Sodium is giving it away to chloride. And when it does that, when it gives it away, it changes the charge of the atom and creates oppositely charged atoms. And again, we'll talk about all that later. But so it's giving it to chloride. Sodium had 1 to give, and chloride took it. Okay, let me zoom back to normal size here. So that's ionic, when it's given or taken. So sodium gives it to chloride, chloride takes it, that extra 1. Then we have covalent compounds, and that's when the valence electrons are shared between atoms. And so this creates a stronger bond because they're sharing them and it's holding them tighter together. I did the same thing here. Let's see. Hydrogen only has 1 on its shell. Remember, it likes 2 to be happy because it only has 1 energy level, and so that first energy level needs 2. And so it only has 1. And so it wants 2 to be happy. Oxygen has 6 on its outer shell. Let's see if I can. So the red ones are oxygens. And it only has 6. So it wants 8 to be full. So if it shares, be yellow. If it shares, let me take those off. If oxygen shares that red one with hydrogen, then that gives hydrogen 2 on its shell and makes hydrogen happy because it's got 2. And if hydrogen shares that one off its one shell with oxygen, then it helps fill that shell. And that's why there's 2 hydrogens there, because oxygen needed 2 to be a full happy outer shell. So that's a covalent bond. They're sharing them. And it holds them together. It makes a stronger bond because they're shared. It's not giving or taking. It's sharing it. They both have it. So yeah, covalent bonds or covalent compounds are 2 or more atoms joined together that share valence electrons. Okay, make sure you took good notes and be ready for your fun quiz.